Hi, this is Ben. Today we are looking at the entire process of building a modern web application, from what users see in the browser to how data is stored behind the scenes. So far, everything we learned from this class, the CSS5610, connects to one big goal, which is creating a three-tier architecture website that links the clients, the servers, and the database. And when a user visits a website, three layers start working together. First, we got the client's layer, which is what appears on the screen. So the structure, the design, and the interaction built with HTML, CSS, and JavaScript, which so-called the front end. And second, we got the server layer, uses Node.js, Express.js to handle logic, process requests, and connect to the data, which so-called the backend. And then finally, we got the database layer, powered by MongoDB, store all the information that the servers retrieves or updates. And all of the three tiers communicate through the HTTP protocol, and which sending and receiving data in JSON format. And we also use MongoDB query language to communicate with the database. And yeah, that's the overall map from the browser, the server, and to database, and finally back to the browser. And that's work through each part more closely right now. When we look at the foundation of web development, everything begins with the building blocks, the HTML, CSS, and JavaScript, which together create the structure, appearance, and the interactivity of every website. In which HTML is the skeleton of the web. It's defined what content appears on a page and how it is organized. Let's dive into it. So first we got elements. Each element uses a tag name and can have attributes that provide additional details such as links, images, or formatting options. And we also use IDs as unique identifier for single elements, and classes when we want to style or reference multiple items in the same way. And every web page follows a consistent structure, which is the header contains meta information like titles or links to the style sheet, and the body contains all the visible content that users interact with. And modern HTML also emphasizes semantic elements such as headers, main, section, and article, which give meaning to the content and help both accessibility tools and search engine understand the page. We also organize tasks using hierarchy heads from H1 to H6, ensuring each section has a clear logical order, but we need to remember always to put only one H1 there. We also have lists, whether the n ordered with UL or ordered with OL allows us to present information nestedly using list items. And we have forms bring interactivity to HTML by collecting user inputs with labels, text field, or we have also bottoms. And all of this content is represented behind the scenes in a document objective model, or we call it DORM, a tree-like structure that JavaScript can access and modify dynamically. Once we have the structure in place, CSS brings it to life virtually. CSS controls how our page looks, including its colors, fonts, layout, spacing, etc. And let's go over it. So it worked through simple rules written as selector. We got property and value, which tell the browser what part of content to style. And some styles are more powerful than others. Like inline style override everything, followed by IDs, clauses, and finally element selectors. It's generally best to avoid using important, which is, yeah, this concept is very important. Things like a forced an override that can create conflicts later. So remember to avoid using important. CSS selector also give us flexibility. We can target elements by class, IDs, or even by their relationship in the document, such as a parent's directed children or a nearby sibling. And there are multiple ways to include CSS. We got inline for small tweaks, internal for quick protocol, and external style sheets for large projects. But we always recommend to use a separate style sheet to make your code more organized. For layout, we have flag box, makes it easier to align and distribute elements in a row or columns, while CSS grid gives us a powerful two-dimensional system for building complex layouts. In addition, frameworks like Bootstraps provide a pre-built grids and responsive component, allow developers to design modern or mobile-friendly pages very quickly. With the page structure and design ready, JavaScript gives our site behavior and logic. It allows pages to respond dynamically to users' actions. And let's go over it. So we use constant to decline variables whose values should not change, and let for variables that may change later. But for here, always remember to avoid using old var, which can create confusing scopes issues. So JavaScript also supports multiple data types, strings for text, numbers for numeric values, and also booleans for true or false conditions. Like other languages, we also support arrays, hold ordered collection of data that include powerful methods like map, filters, and reduce for processing information efficiently. We also have objects, on the other hand, store data in key value pairs, and can include methods to perform actions. They will also support define functions, whether traditional declarations or modern array functions, which let us reuse the code more easily. Modern JavaScript also handles asynchronous tasks using promises and async-await syntax, which makes operations like fetching data from remote servers much easier, no matter to read or write. We can also organize our code into EX6, which organize our code into modules using import and export statement, help keep our projects clean and maintainable. Most importantly, JavaScript manipulate the DOM. It can select elements, change their contents, and respond to events like clicks or key presses, which creating a fully interactive experience for users. Moving beyond the front end, let's close all of that first. Close this. Yeah. Okay. Web development extends into architecture, which is how clients, servers, and database communicate. So I got two kind of architecture, the two-tier, three-tier. So we go with the two-tier first. So in a two-tier architecture, the browser client directly requests static HTML, CSS, and JavaScript files from a server. This is also the simplest model. So there is no database, just directly content delivery. So the communication happened through the HTTP protocol, which defines the methods like get for retrieving data, post for creating new data, and put for updating, and also delete for removing. So this client-server interaction form the foundation of all web communications. So we're going to move on to the three-tier. So as the applications become more dynamic, we shift to a three-tier architecture, consists of the client, servers, and database. In this model, the clients display the user interface, the application servers handle business logic, and the database manage persistent data. On the server side, Node.js allows us to run JavaScript outside the browser. Express.js provides an elegant framework to manage routes and the middleware. And we define API endpoints, specific URLs to respond to requests and return JSON data for the front end to use. The database layer is powered by MongoDB, a document-oriented database that stores data in flexible JSON-like documents. Developers can hold database locally with Dockers or remote on MongoDB Atlas, using tools like Compass or Mongo's command line to export data. Each document in MongoDB is stored within a collection and contains key value fields similar to JavaScript objects. And the queries are written in MQL, like mentioned before, the MongoDB query language, which let us find, update, and project specific data. And query operators, which is also important, help refine these queries for powerful search. And more advanced analysis. MongoDB provides the aggregation pipeline, which process data through multiple stages, such as match, group, sort, to generate reports and summaries. And together, those operations define the four essential cross actions, which is create, read, update, and delete, form the backbone of data management in modern web applications. So to sum up, we connect all these layers, we get a complete end-to-end workflow. A user interacts with the HTML elements styled by CSS. JavaScript captures their actions and send an HTTP request to an express route. And the server processes the request, queries MongoDB using MQL, and send back JSON data. Finally, JavaScript update the DOM dynamically to reflect new information. And this flow from user interaction to database and back to the interface is what makes modern full-stack web application both powerful and interactive. From all the topics, I would like to focus on one of the most important ideas in modern web app development, which is asynchronous JavaScript. So everything makes a website feels fast and responsive depends on this idea. So why asynchronous programming matters? So JavaScript runs on a single thread, which means it can only do one thing at a time. If a slow task, like finishing data or reading a file, blocks that thread, the entire pages would freeze. So instead, JavaScript uses asynchronous execution. It can start a task, moving on to another work, and then come back once the task finishes. So think of like ordering a coffee. You don't stand at the corner, do nothing until it's ready. What you can do is you can sit down, you can check your phone, maybe talk to a friend, and when the stuff call your name, you can go pick it up. That's a callback. So that's exactly how asynchronous JavaScript works. So how the event loops keeps the page alive. So behind the screen, JavaScript uses an event loop to handle all of this. The main thread runs synchronous code line by line. When it reaches something slow, like fetch, call, or a timer, it sends that task to the browser's background system, known as web APIs. And those APIs handles it separately, and when they're finished, they put the result into a queue. And when the main thread becomes free again, the event loop picks the next item from what the queue and runs it. So that's why even though the JavaScript is single-threaded, it feels like it's multitasking. So there are three stages when we use asynchronous JavaScript. So originally, developers handles a single task using callbacks, passing one function into another one and run later. But when you have callbacks inside the callbacks, and the code quickly become messy, what we call it callback else. So then comes promises, which represent a value that will be ready in the future. So you can attach them and catch handlers to process that values when it arrives. But promises make things cleaner, but long chains of things still got confusing. But finally, we got a single await built on top of the promises, but write like normal step-by-step code. It's simple, readable, and easy to debug, and that's what most developers use today. So what non-blocking really means and why that is important. When we see, let's click on to the next page. When we see asynchronous code is non-blocking, we mean the page doesn't freeze while we wait. And the keyword await pauses only inside the current function. It doesn't stop the whole browser. So the user can still click or scroll or just type when data being finished in the background. And that makes the web application smooth and the interface never locks up. And jump over to the next topic, handling errors gracefully. So we need to remember never request can fail. So we always need to check for errors. And what we do is we use this try and catch to handle failures without crashing the page. And we check response okay to make sure the servers actually return something valid. And that way our application can show a friendly message instead of just breaking. And this asynchronous logic isn't just for browser. It's also works for the server side. Node.js Express uses await db or await finish, so one server can handle many users at once. And this single concept, async execution, is what keeps front end and back end responsive. Okay, enough talking here, but it's still hard to say why this concept of asynchronous really matters. So I prepared a Pokemon search engine, super simple one right here, to quickly show how important asynchronous is. And I set up 3 buttons right here, one for blocking code, and one for search Pokemon, and one for randomly selecting Pokemon to show. And let's jump over to the coding part. So right now I'm just going to define this blocking sample function, which is just to show how the page without asynchronous gonna froze the whole page. Let's add the task on the page, just let the users know there is a slow task running. Let's do status. Alright. Task content because let's say running a slow task. And for here, we actually do nothing but just to show I set up a 3 seconds slow task. I'm gonna do this. Sorry. I'm just gonna set up this while loop to how 3 seconds work inside. And now still minus the start. 3 seconds. Yeah, this while loop just doing nothing. It just stuck the loop and blocking the thread for 3 seconds. And then we're just going to change the task again to show the task is done. Okay. Task done. Yeah, let's see how it's work. I was just gonna refresh the page. So right now we just defined the logic for the blocking code button right here. Just do the inspect, and let's see what happened when I click on this. Oops, sorry. Yeah, you can see like when we click on it, after 3 seconds I can click on other buttons, but if I within 3 seconds I cannot click any of them. That's the basic idea right here. So let's now define another 2 button with the logic of asynchronous JavaScript to see like how it can handle multitask. So now let's build the asynchronous version, and I define this asynchronous function called load Pokemon right here, which led me to use a wait insight. And just to save time, I'm just gonna copy paste what I wrote before, and I will explain one by one. So for this part, I just clean up whatever the user typed and remove the spacing and converting it to lowercase. Yeah, let's do another data cleaning. So right here, this part, just show if the input is empty, I show a message asking the user to type something or just exist the program. So now I displayed a loading message, add a CSS class for the spinner, and temporarily hide the Pokemon card until the data arrives. And now is the important part. We wrap the network request in a try and catch, so we can handle errors gracefully. And we're going to try. I'm going to copy the URL here. We're going to fetch the data from this URL. So here is the important part. So I'm going to use finch to send network request and wait to tell JavaScript pause the function until the results come back. But that don't freeze the page. So during that time, our other code can still run without waiting it. We can do constant. Yes. This URL. Okay. Yeah. I'm also gonna add a fake 2-second delay so we can actually see the loading states. It's right here. This makes the difference between the blocking and non-blocking easier to just visualize. this line right here is for after the response arrives, I check if it was successful. If the servers returned an error, I threw my own error to jump to catch block. After that, we do this. This part is just for best available image from the APIs. So just set on the image elements. And finally, once everything's ready, we show the card again and change the message to done. It's like this. So we finished our try. But we're still gonna throw the error case. Video catch. So if anything fails, like a bad networking connection or wrong Pokemon names, we hide the card and show the error message instead. Do this. This. And finally, no matter what happens, I remove the loading spinner so the interface looks cleaner again. So I do this. I'm gonna do remove the loading. Okay. That's basically what we got. Let's save and refresh the page to see what happens. Let's see if that works. It's loading. Yeah, it works. So as we can see, there's a 2-second loading time. After 2 seconds, we can see one Pokemon pop up. And this is a synchronous function. So what that means is if we click on that, it's loading, but it's loading during that time, we're still gonna able to click multiple times. So the page never froze. And that is what asynchronous JavaScript basically means to make like modern web application faster and responsive. So that application wraps up our deep diving into asynchronous JavaScript. And thank you for watching. And I hope this helped make the concept cleaner and more practical. Thank you.